Our next speaker I'd like to introduce to the stage is Dr. Pablo Ferrero from AIMPLAS.
Well, first of all, I would like to thank the organization for this great event and the opportunity to be here. And I'm going to talk about what AIMPLAS is doing to pave the way for the circular bioeconomy of plastics. And first of all, let me now to introduce what AIMPLAS is. Well, AIMPLAS is a technology center with more than 30 years experience in the plastic sector. Our purpose is to add value to companies, to generate wealth and employment, and add value to society to improve the quality of life and ensure the environmental sustainability. Okay, so we provide knowledge to the companies to improve their processes across the entire value chain of plastics. We work across the whole value chain. We work in polymer synthesis. We work also with raw materials. We work with compounding in this additivation process that is quite important to give the properties to the different polymers. Also in processing and manufacturing, in extrusion, injection molding, in our pilot plants. End users, we work with end users, and also in the recovery of plastic waste through mechanical, chemical recycling, biochemical recycling, and enzymatic recycling that we have seen in the conference. And but we are not only limited to plastic waste. We are also working with organic waste to convert them into biopolymers, bioplastics, chemical building blocks that are important for the plastic industry. Okay, so the activities in AIMPLAS can be classified in three kinds of activities. The first one in research and development to provide knowledge to the different companies. The technology services to measure characteristics and properties of the plastics and polymers. And the last one that is also quite important for us is the training and events. So as an example of what we can do in research in bioplastics, in the biorecycling, one of the best examples is the BioICEP project. And I will show you some of the main results of this project. The overall concept of the project is to convert the mixed plastic waste that cannot be recycled at any way. This waste goes to landfill, convert it into bioproducts and biopolymers. Okay, the steps are quite complex, but we can resume. Like first of all, we have a triple action depolymerization where we combine different techniques, physico-chemical techniques, coupled to microbial and enzymatic approaches to depolymerize, obtain the monomers, and with these monomers, if they have the purity enough to be repolymerized, we can repolymerize, and if not, we can follow the next step, the fermentation, and we can ferment different monomers from synthetic plastics and obtain these biopolymers and bioproducts, the PHV, nanocellulose, and rhamnolipids. So the main contributions of the BioICEP project is material pretreatment options. We have developed different pretreatment. Here is just an example of reactive extrusion of polyethylene, a known polymer non-biodegradable. And with this pretreatment, we convert it into more amenable for biodegradation, which is quite interesting. Also, we have power in the diversity of microorganisms. We have isolate different microorganisms that have the ability to hydrolyze the different polymers. And in this regard, in AIMPLAS, we have a microbial biobank with all of these different strains. And also, we have developed smart screening strategies to know or to quantify the hydrolysis, the enzymatic hydrolysis against plastic. So we have synthesized different compounds that their structure is quite similar to polymers, but they have a characteristic. For example, they are colorimetric properties. So we just in a simple way, we can measure the hydrolysis activity of the different enzymes against plastic. And also upcycling strategies. The overall project is an upcycling strategy to convert mixed plastic waste, synthetic even, into bioproducts or biopolymers, like also biopigments. So we are working using plastic as feedstock, but we are not limited to that. And we can also work with biomass feedstock to produce biopolymers and biomass valorization into bioplastic to produce PHV, and then close the loop using the enzymatic recycling technology. Also, the other activities that I mentioned before is technological services, focus on analysis and testing to characterization of plastics. And in this regard, we have developed a tool that predicts the biodegradation of plastics, in this case in soil conditions. And this tool can help to design the biodegradable plastic in these conditions. Because the thickness, for example, is an important parameter. We can blend and we can predict the behavior of biodegradation of the biodegradation polymers in soil conditions, and we can help in the design of the polymers. Also, this tool can help in shorten the biodegradation test, because in soil conditions this test can last up to 2 years, and is too much for the industries and companies to put something in the market, and it can help also to know the useful lifetime of different products that are applied in soil, like controlled release fertilizers. Also, we are working in the optimization of biological processes, fermentation, and waste valorization to produce lactic acid, PHV, other chemical building blocks. Also, we are working in bioprospection. As I mentioned before, we have a collection of microorganisms with different abilities to produce enzymes that can degrade plastics, but not only limited to that, we have also isolated microorganisms that can produce lactic acid or other organic acids. And also work in the identification of the genes and enzymes responsible to the degradation of plastics. Also, we have capabilities in biodegradation tests according to the standards. We have a laboratory certified to do this kind of test, composting in industrial, home composting, anaerobic biodegradation, the biodegradation in soil conditions. And also, we have developed some tests to ensure the safety of plastics in food contact applications regarding the cytotoxicity and genotoxicity test. And also the last activity that are important for us is the training and events. Here you can see the number of training and events that we have done in the last year. And in this field, we are quite flexible, and we can adapt to the companies with online courses, face-to-face training, tailor-made courses. And here, the next webinar that we are going to do is a webinar focused on fermentation as alternative for production of biopolymers. That is interesting. And other event that can be quite interesting is the seminar focus on plastic recycling in next November. So I would like to invite you to join us in Valencia, in Spain. And that's all from my side. So thanks for your attention.